In this lab, we will show how an object with no forces acting on it will have a constant velocity. In this lab, I rolled a yellow ball at a constant speed, and this was proved nearly constant by Tracker. The system in this lab is, of course, the yellow ball. It is 0.0141748 kilograms. In order to try and simulate constant velocity, there shall be no intended forces interacting with the ball. Here's the video that I analyzed in Tracker. As you can see, I created my graph so that the positive x direction goes to the right, and so that the positive y direction is up. I calibrated the video to show Tracker that the distance between these two doors is 0.6 meters. Next, I modified the startup program. But before I could modify the startup program, I had to first compute the velocity. Here is my start time and my corresponding start position. Here's my second time and my corresponding second position. Using the formula to find initial velocity, we discover that it is in fact the vector -3, 0, 0, or 3 meters per second in the negative x direction. So now we go to the startup program. Oh, sorry about this. Here it is. As you can see, I have inputted the ball's mass here, the start position here, and the initial velocity here. Of course, the net force is vector 0, 0, 0, as there can be no intended forces acting on the ball during constant velocity. Now, here is the model. When I first created the model, I found that the ball traveled to the right, but in real life and in Tracker, the ball moved to the left. So, to make the ball move to the left, I changed the velocity vector to -3, 0, 0, and now the ball moves to the left as it should. Finally, after taking the data from Tracker and from Python, I went into Google Spreadsheets and created this graph. As you can see in this graph, there's a slight discrepancy between the experiment position and the model position. There could be several reasons for this difference. For one, the ball's mass was very small, and I rolled it on carpet. So friction would have affected its speed and velocity effectively, and it would have made a large difference. Also, since the video in Tracker was blurry, I may have miscalculated the center of mass of the ball in each frame. And also, finally, although it wasn't evident in the video, the ball was moving slightly to the right, which would have made a difference, as Tracker is only two-dimensional. However, we could have found the results of this lab that you cannot have any net forces acting on an object to have constant velocity through simple algebra. As you can see here, here's the formula for finding the change in velocity. It is the initial velocity plus the net forces divided by the mass times the change in time. However, in order to have constant velocity, the net forces, of course, must be 0. So then the formula becomes like this. The change in velocity is equal to the initial velocity plus 0 divided by mass times the change in time. However, since you cannot divide nor multiply by 0, all those three terms cancel out. Therefore, the change in velocity, and therefore the new velocity, is actually equal to the initial velocity. I hope you enjoyed my lab report, and thank you for watching.